Ever wondered how the universe really works? Or what secrets history left behind? You are about to find out. Every gold ring, every gold bar, and every vault on Earth, none of it was made here. Not a single atom. Gold doesn't come from the ground. It doesn't come from volcanoes. It comes from the death of stars. And not just any death, the most violent events the universe has ever produced. To understand where your gold came from, we need to go back billions of years, to a time before our planet even existed. Stars are enormous fusion reactors. Deep in their cores, hydrogen atoms smash together under crushing pressure and become helium. That's what powers our sun right now. As a star ages, it fuses heavier and heavier elements. Helium becomes carbon. Carbon becomes oxygen. Then neon, silicon, and eventually iron. But here's the problem. Iron is the dead end. Fusing iron doesn't release energy, it absorbs it. So when a massive star builds an iron core, it's essentially building its own coffin. The core grows heavier and heavier, until one day, it can no longer support itself. And in less than a second, the core collapses. What happens next is a supernova, one of the most powerful explosions in the universe. The outer layers of the star are blasted outward at tens of thousands of kilometers per second. For a few weeks, a single supernova can outshine an entire galaxy of 100 billion stars. Now, supernovae do produce some heavy elements. The extreme temperatures and pressures during the explosion can forge elements heavier than iron, including small amounts of gold. But here's what scientists discovered fairly recently: supernovae alone can't account for all the gold in the universe. Something even more extreme was needed. After a supernova, if the original star was massive enough, its core doesn't just disappear. It collapses into a neutron star, an object so dense that a teaspoon of it would weigh about 6 billion tons. Now imagine two of these neutron stars orbiting each other, spiraling closer and closer over millions of years, until they finally collide. This is called a kilonova. And it is gold's true birthplace. When two neutron stars merge, they produce a flood of free neutrons so intense that atoms can capture them faster than they can decay. This is called the R process, rapid neutron capture. And it builds elements all the way up to uranium. A single kilonova can produce several Earth masses worth of gold, flung out into space at a fraction of the speed of light. In 2017, scientists actually observed this for the first time. Two neutron stars collided 130 million light-years away. The gravitational waves were detected by LIGO, and telescopes spotted the unmistakable glow of freshly forged heavy elements, including gold. So the gold was forged in space. But how did it end up here, on Earth? About 4.5 billion years ago, our solar system formed from a massive cloud of gas and dust, the remnants of older stars that had already lived and died. That cloud contained every element those dead stars had produced, including gold. As Earth formed from this material, it was a ball of molten rock. And because gold is so heavy and dense, most of it sank straight to the center. Earth's core is estimated to contain enough gold to coat the entire surface of the planet in a layer 1.5 feet thick. But we can't reach it. It's thousands of kilometers down, trapped forever. So where did the gold we actually mine come from? The answer is space. Again. About 4 billion years ago, during a period called the Late Heavy Bombardment, Earth was pummeled by a storm of asteroids and meteorites. These objects had been drifting through the solar system since its formation, carrying heavy elements, including gold, on their surfaces. The gold from these impacts stayed in Earth's crust and mantle, close enough for us to eventually dig it up. Every gold deposit on Earth, every mine in South Africa, Australia, California, traces back to these ancient cosmic deliveries. The gold in your jewelry is literally stardust, forged in a neutron star collision billions of years ago, delivered to Earth's surface by asteroid impacts, and then concentrated by geological processes over millions of years. So the next time you hold a piece of gold, remember you're holding something older than the Earth itself. Something born in the collision of dead stars, scattered across the universe, and delivered here by falling rocks from space. Gold isn't precious because it's rare. It's precious because of what it took the universe to make it. If you learned something new, subscribe to Chronos Lab. We make the universe make sense. Hit the bell, and we'll see you in the next one. If you enjoyed this, smash that subscribe button and hit the bell. New science and history videos every week. See you in the next one.